This constitutes all available data. That information is not available.
The most logical course of action is to transport me to safety with all due urgency.
Korak, what are your limits?
They have not yet been defined. My knowledge is virtually infinite. My secondary ability is to logically process that knowledge and make accurate predictions. Instructions are not needed if commands are succinct. That is better. Our relationship will be best served if your statements are free of ambiguity.
There seems little point in wasting time on such an explanation, since you would be incapable of understanding it.
It is an immutable certainty.
I am checking. Kindly wait. I have the information you require. I must assume that your request is a frivolous one.
Good afternoon. Hope you're all okay. Right. Bit of an interim here going on. We need to make a little bit of an interface, so let's get on with it. Okay. Let's bring it up to the front. There we go. So, spent this morning just getting everything set up. Rewiring the test bed and just preliminary setting out and creating a sort of creating this bit of a relay logic diagram. So just to see what kind of signals we're going to get, we need to start with some signals and come out with some, and they need to the timing chart, so it probably needs to be called timing chart. Anyway, before we go ahead, I'll just get it clear in our head what we're trying to do. It's nothing worse than trying to program something and you're not clear from the outset what you're trying to do. Anyway, this is the FAS Walkway, pedestrian walkway, and it's got to interface to a robot I/O controller. The I/O controller is expecting different signals, and the walkway is a bit more strange, I suppose. Just works off push buttons and contacts, so that's no longer any good. Designed for a pedestrian to press a button and let go, and then the system take over. But in order to work with other systems, the other kinds of signals are required. So that's what we're trying to do today. The easiest way we can do it is that we can alter quickly or add stuff and remove stuff, is to do it with a smart relay, but a smaller version. So going back to this software here, so let's have a look at it. So we've got a list of paperwork we've got to adhere to, so we need to get a few things in place, triggers and things. Let me just check we've got audio to do with, we have audio, okay. So various flags and steps and modes and things. So the walkway, so walkway PED request impulse from the walkway button. So we've got a button on a post, a normally open button going closed when the user presses it. The user can press it, either hold it in, press and let go, and the time for that is random, whatever they want to do. They can lean on it, start chatting and forget they're holding it, or hit it quickly and let go, or it could even get stuck in. So that signal needs to get converted into something. Now the walkway system will remember the button press, but it then starts the system off as soon as the system is ready. So what we want here is we need to remember this button press still, because this other new system that goes in between the two systems will need to remember the signal before it passes it on to the walkway system. It can't pass it on to the walkway system unless certain other system is ready, including the walkway system. They will have to be in the right condition. So again, it's got to remember it. So we take our push button press straight into a set reset latch, and we have a little indicator. There's your set reset latch. Normally open, going close when they press the button. In fact, we could probably turn that into a button if need be. Let's pretend it's a button, which it is. So there's your push button. Doesn't look like a push button, does it? It's a bit of a crude representation of a push button, that is. But anyway, what else have we got here? Limit switches, proximity. Oh, there's a better one. That's it. Nice push button. Okay, you can put a custom one in if you want, but that's fine. All this is, the descriptions have to be succinct and the buttons have to be appropriate and the icons, because you've got to follow this through. You've got to follow the signals through, and it must be free of ambiguity, otherwise you just get confused. Anyway, I've come home to work on it this afternoon because in the workplace there's too many interruptions. You've got people dropping parcels off, mail being delivered, phone calls, technical queries, different things going on, and the level of concentration to get this to be in a position where it can be tested and tried, it's quite high, even though on the face of it looks a simple circuit, but it's not as simple as they're never as simple as they seem to be. So we've got to try not to over-engineer it, keep it as simple as possible, but we've got to satisfy some of the criteria. So we'll do it bit by bit. So we've got this other chart as well. So this will basically be a timing chart. So when the push button is not pressed, we get a steady signal. When we press the button, you get a high value coming through, and that could be a momentary pulse, but then it has to latch one of the other states, and that has to stay latched. But this is, it's difficult to do because some of these signals they're waiting for other signals to be complete. You can't truly align them up in a timing chart. So I put it there just to try to help, but sometimes it's not going to help anyway. So we'll go back to the other one. Right, so back here again. So we've got our button press. We've set it through a set reset. We're not doing any reset at the minute. We will be, and it sets the flag. And if we do a simulation and we click on run, at the minute all you're going to do, if I click that button down, you're going to get a high signal there. It's going to set the set reset latch. Your indicator PED request received flag. That's a flag. So we ought to call that a flag, really. Let's do that now. Let's just change that. PED request received flag. So basically, it's flagging up to the system. It's flagging up that the system has received a PED request. So if you go back to simulation and you click on run, so if we give that a permanent value, you've got once it's set, it's set. If I unpress the button, it stays set. If I keep pressing it, nothing happens. Nothing changes. Okay, that's fine. So we might introduce this set flag. We might do something with it. So this will basically take any length of signal, any kind of signal, whether it's a quick one like that or a long press, any kind of signal. So I'll pass it through to this. So this then, once the PED request has received flag is high or triggered or set, it needs to go through to some kind of Boolean, some kind of logic that evaluates other signals before it can send it on. That's that bit there. So this is the one that we're going to be tying in with it, so we can put that like that. This will not pass a signal through to the PED mode active flag. So let's rename that as well. Might as well go along with the flag idea. That's an internal indicator. It's an output, but it's an indicator internal, just to light the program up in a certain way. I'll just spread it around a bit. Okay, we can afford to go back a touch. That's too much. Right, so we've got our PED request received flag. That'll be set, and that's just to remember the fact that someone's pressed the button. System might be busy doing other stuff, can't process it directly. So it passes it on through the Boolean, and the Boolean, compared with other criteria, will be able to see whether it can set the PED mode active flag. Okay, so once that flag is set, we're in pedestrian mode. Okay, now once we get into pedestrian mode, we can send a pulse over to the walkway system. We're doing that. We've got a static flag that's on, but we need to create a signal. So what I'll do, I'll go into here first. You get the Boolean come up, and I'll just say, in order to get this to flow straight through without any other criteria, we're just going to say that one. So basically, when everything else is off, the first input is on. So you get input 1 to 4, so you got 1 to 4. Input 1's on, and then output will be coming on. So we get that to come on, and that'll start. So that'll start this. Let's have a look at that one. It's a timer lie, cyclic timer. Probably don't need the cyclic timer, so let's see if we can find the right one. It's not quite the right one, that one. I can't remember which one it is now. Cyclic timing, pulse on edges now. Can't remember which one it is now. Let's just try that one. Yeah, this is it. Yeah. So this will give us a pulse, should do. So as soon as we get this PED mode active flag on, we want a pulse. So basically you need to come on straight away, and you can come on with a delay. We can give it a couple of delay, so an off delay. So this just needs just an half a second pulse. Tell you what we'll do, we'll give it a whole second. 10.1s of a second is a second. So I'll give it that, and we're going to replace that one with this one. Alright, and that's just going to give us our pulse output over there. In fact, if you wanted, you could put another thing on there, but you'll see it lights up anyway. Right, let's name it. So it's going to be called our
20RYR portable
request
Q4 TCU calling.
impulse. Ped request impulse. And that goes...
Yeah, you're very weak with me. You're very weak. I'm in the West Midlands. I'm not sure whether you've got a directional aerial or not.
Right,
Have you
so
got frequency?
we'll try all that out now. We'll do a simulation and run it. So when I press this, it can be a quick on off or whatever, but it will initiate this
Yeah, 450, see that?
10-second pulse here. So here we go. No, it's not counting. That's because we've got a continuous signal. So what we'll probably have to do, I mean the other one worked, but right, so what we'll have to do is introduce another item here, pulse on edges. So we're going to tell it we want to pulse on a rising edge from off to on. Yeah, that's right. So I'll just get rid of that one a second, put that one in its place, and we'll fasten that to there. Okay, and that should give us our pulse, which takes away from the, as soon as it sees it go from low to high, as soon as it's set, it'll give a pulse out. Let's just try that. Oh, we didn't click on run. Right, here we go. It didn't give us anything, did it? Let's just check that. What have I done wrong? Let's have a look.
G5CS, G5CS, G0WEB Marble.
Oh, it's got a 2-second on delay. Ah, yeah. When we got a pulse, we can't have any on delay. Otherwise, it'll miss the pulse. That means it has to be held on for 2 seconds before it'll give us an output. So that should now then work. If we try it again, so I'll just give that a click pulse. There we've got our 1 second pulse. Try it again. We can't actually try it again because once this reset is latched, that's all done. So what we need to do is basically reset this based on this. So, and we've got this output, so we need to drop the output off. So once we get our pulse out of here, we can reset our latch. So let's do that now. Reset our set latch. Oh, I can go there actually. It's out the way there, isn't it? Right. Okay. Let's see if that will work. Should be fine. So give it a quick plus. So you got your 10-second pulse, and it's reset the flag. Try again. So you can do this indefinitely now. So you're always going to get a 1 second pulse out of that. Oh, there is a problem with that actually, because that needs to be a continuous voltage. That needs to be a continuous signal when we're in this mode. Because so once that is set, yeah. So we've got to pass this signal on. So once this is set and we've switched on this mode, it's that point then it needs to reset it, not further. But the only thing holding this on, once this mode is gone on, it needs to be set. So we need another set bit. Sorry, we should have put another set bit in there. So just bring that down a bit. So we need another set bit on here. Now it can only set if certain criteria is met. So I'll put the criteria back here. We're going to unwire this for a minute, and that, and that. We're going to have to put in there a set the flag on. So once that's gone onto there, we need to be able to set it, and obviously we need to pulse that on and go out to the once it's set. Right, try and keep it all lined up, just to keep everything neat. Otherwise, once it gets complicated, you'll lose yourself in it. Right, so we've got our criteria. Let's leave that there. Our set bit. Right, can afford to go up a bit. Right, so a lot of it's juggling around. So we come into there. We set this latch. We can reset the latch. Now it needs to come off, not this end. So it needs to come off this set bit. As soon as this is set, yeah, because remembering the flag until this is set. So once it's set, we can reset the input one. Right. So as soon as this one gets set, and even if this system here is not ready because the boolean's not satisfied, it still remembers it. And as soon as the system is satisfied with the rest of the criteria, it will allow the signal to go through to this set latch. So once it's set, then we'll be outputting. The PED mode will be active. You'll get your pulse, and you'll also get your continuous signal based off that. So let's save, simulation, run. Right, so we give it a quick pulse. So I saw that come on, that's latched, and now that's output there, and it's reset this one. The problem is now, because it's continuously holding the reset on, because it's outputting, you're not going to be able to set it again. So any subsequent people it's going to miss. So what we need to do is introduce into there a pulse like that again. So which one is it? Is that the one? Yeah. So we need to basically put that into there to reset it. And we need to output from here over to there. So once this gets set, we can just clear it, because we've used the flag up until that. We're remembering it up until that point, and once we've remembered it, and once we've used it by setting this flag, we can clear it. It doesn't need to be remembered unless somebody comes along and press again. So this one needs to go when it sees a transition from, only execute when it sees a transition from low to high. From low to high, which is that one. Right, let's see what it does now. This is where it gets complicated. Right, so give it a pulse. You got your 1 second pulse, and you got your continuous, and you've got your flag was previously set. No, it's still set. Why is it still set? So it's still set. I've got it there, and it should be reset now. so it's set, so yeah, it's not quite right. Not quite right. So we've got a continuous output. Now, was it because if I just do a reset? Hang on, where's my other set flag? Let's reset that one. Oh, there. Oh, I can't do it from there. Right, stop it and start again. Let's try to follow it. So this is why it takes so long, and that the other walkway system was huge. This is much simpler, but yeah, so at least we can follow it. The level of concentration is needed, so you get interrupted all the time. It's not, you lose where you were trying to, you know, so it's not good. So we run. If I give it one pulse, yeah, so we've got our pulse. The flag was set. We've got an output. It's passed the output to it, but it's still set, I think. Let me just try one more time. So I'm going to look out for that. If that goes red, let me look out for that. Ready. So it did a pulse. It went from low to high, and it gave the pulse out enough to reset it, but for some reason. Okay, so let's try it the other way. From on to off. It's never going to be on to off, is it? From off to on, and right, that's, I don't know what's going on there, unless right, I think there needs to be a delay. Yeah, because if I'm holding that, oh, the time is here, isn't it? That's the 1 second. It comes on straight away. So basically, it's resetting the flag. It's the right setting. As I press the button, I'm holding the button longer than the pulse for this. So in that case, it's resetting it before I've let go, basically. So we could probably do the same again. So we get into that's not the wrong one. Let's go here. So we've got ourselves a little. What's that doing? Display comments all. Right, I've clicked the wrong one there. Right, block numbers none. So we've got a transition from 0 to on, and we get a pulse. So basically, when I light that up, it'll give me the 1 pulse. Let's try it. And it'll allow then this reset to take effect. But only if I've let go. Yeah, it's actually cleared it, look. So let's set it again. But because it has never cleared it, because it needs to reset that, so you have knock-on effects. So you've got to wire different inputs, outputs to different parts to reset it. It's difficult because might not need all this. Let's just go through it. Right, so we've got an output triggered there. We're set. We can't get a reset because our criteria isn't looking at anything. Yeah, we have to rethink this slightly. Let's have a rethink about this. So you've got to remember the pulse. So we must remember the pulse. We remembered the pulse. So if we had something, it didn't solve the problem. The best to get rid of it. Don't add stuff if it doesn't solve the problem. Now this reset here, see that's a bit there. When it transitions from low to high, it pulses this. But we don't need it to reset that input at that point. Well, it's nice to clear the flag. It's nice to clear the flag once this is set. And if you get another press after, then so be it. But you know it's another request. Could be more than one request. Right, so we're not using the Boolean yet, so we're coming straight in. In reality, once the Boolean is set, you won't be able to get another pulse out of it. It'll go off. That's only outputs to there. I'm just telling it to come on straight away so I can test it. Right, so you have to break it down into problems. So why it takes so long? It takes a couple of days to do this. Let's have a think. So what we're trying to do is, when this gets switched off, it's got to give us a pulse. Now as soon as it gets switched on, it gives us a pulse to clear that out. But we can't clear that out because that happens instantaneously. So what we've got to do is so as soon as that goes on, it switches, it resets this flag, because then this mode has taken over the previous flag. That's the request. So take your request, remembers it till the system's ready and the criteria is satisfied, then it'll set the flag. Once that's set, this can be reset, but it can't hold the reset onto it because it's got to remember another time. So that's why we did the bit of a so we got it to reset it, but the second time it gets reset, let's just go through it one last time. I have to keep simulating it. Right, so we go like that. So we've got our permanent signal coming out. The flag is not reset. It's not reset because my pulse is longer than this one. This happens instantaneous, so, and we don't know. It needs, probably needs a delay. So delay this output. So it's giving you a pulse straight away. So, maybe we look at this pulse. Yeah, so as long as this is set, yeah, so it needs, this is a problem. Let's put something to listen to in the background. I can just stop talking, carry on. Alright.
Online, but yeah, it wasn't, so I didn't bother to give you a call or mate, so sorry about that. Cancel from Lab 0 WNT.
G6DP. Yeah, don't worry. What did I do? I left my node on for a while and I didn't hear you call. And in the end I shut down, but I can't remember what time
Let's just leave that in the background.
I didn't get a bed till about 2:30 this morning.
Right.
Just sort of playing around.
So we get our pulse coming out of here.
I didn't do any more with the hat. Saying I've now got the hat in front of me.
I thought I got two things. So it pulses this out, and it's still set because so. Now we put, hang on, redo. So we want to, let's put that back again, temporary. I was picking up both of them. Right, let's try it again and see where we got so far. It's been a while since I did a major bit of programming. So it's cleared it. Now it's taken its set, so it can't clear another one. So as soon as I do that, excuse me, it's going to remember it. But that's okay because it's remembering another press, but we're already in pedestrian mode, so the pedestrian would have gone through. So if we're in the mode, then there's no reason to remember another one. It's only if we're in the opposite mode, if we're not in the ped mode. So really, in that case, it could just go straight to it then and reset it. Let's just have a look at that. Maybe I misread it. So go straight to there. From there, straight to the reset. Right, simulation, run it. So we give it a pulse. We've got our seconds and we've got our permanent reset. This is ped mode, so it doesn't really matter what we do here. It's reset the flag. It can't take any more. There's no point in taking any more because you'd only have to reset it anyway. We're in this mode. Until that mode is clear, it won't allow you to give it another request. That's fine. We've gone from ped request flag to, well, if we stop it and run it, we're clear. We give it a pulse, it triggers it based on criteria. You get your pulse going out to the actual walkway system, which tells it to, but only based on this criteria. Yeah, that's okay. That's okay. I didn't correlate that once this is set, we don't need to worry about more inputs. We only need to remember that when we're in a different mode. And if we're in a different mode, there won't be a reset on here, and it'll allow it to remember it. So that's fine. That's Zen, pure Zen logic. So it's okay. Right. So far so good. So that's part of the system. Now the criteria, we haven't hooked up with all the rest yet. At some point, the other part of the criteria will reset this system, turn it off. Right, so far so good. This is okay as it is. So that can be moved over a bit now. And we can bring this up together. Let's free up some space. Yeah, keep it nice and neat. Free up a bit of space, that's fine. So our mode flag can come over a bit. Keep it in the middle. We'll keep all the mode flags in the middle. Keep them in the middle. What's that doing? Yeah, we'll keep them in the middle. Let's just keep it like that. Right. Right, there's your boolean. So I'll tell you what we'll do. We'll keep the boolean one side, and then the mode flags somewhere else. Let's bring that up there like that. Bring that down a bit. That's it. Okay, try to keep something going on it. Something like that. Okay, that can come over a tiny bit. Oh, when you hold it, it brings up for some reason. That's it. Okay. Right, so we've sorted that out a bit. Now, probably this could go up out the way. Let's bring that up out the way. Yeah, sort of feeding back into that, that's fine. So we need a bit more space here. So the Boolean will bring over to there. So we've got our flags and our Boolean, input stuff and output stuff. Average barriers are open, so this needs to line up over here. That's more of our outputs though, isn't it? Yeah, that's more of our outputs. So I could think I'll have another flag over here actually. Let's paste that over there. So we'll have indicators lighting up, so I'll just come back a little bit here. We'll have the flag there. I need to be able to read it. PED impulse. PED request. Oh, that's on here. No, you're not going to see that. Oh yeah, what am I doing? That's the wrong one. We want it down on this one, not that one. So that's going to be a 1/2 second pulse. You're not going to see that. So we can go up a little bit with that. Okay. Right, so that's fine. That's our pulse, that's fine. So on this one we need to probably have a little flag here. That's the same flag as that though, isn't it? Yeah, that'll be confusing, so we'll leave that flag off. Yeah, we'll leave that off. I think I'll drop that one and that one like that. Can I drop that one sort of, and this one, and bring that down there? Yeah. Okay. That could probably go up a bit actually. And that could probably come down here. Yeah, we'll leave it like that. That's it. It's got to look neat, otherwise you can't follow it and you're trying to debug it. Try and keep things the same distance apart. Easier to read the diagram. Keep them spread apart the same, you know. Right. Okay. Right, so we've got this section done. So let's give it a once over now, make sure we haven't messed something up. That's overflowing there, isn't it? That's okay. Right, so we give it a pulse. That's a permanent pulse, so we've got our PED mode active flag. We've had our pulse, we've had our continuous signal, and we've got a continuous reset on, which is reset our flag, and we've got a permanent pulse which is getting ignored. Doesn't matter because we're in this mode. And if we was to come out of this mode by resetting it, I don't know if I can reset it. No, I haven't got anything on it, so it won't let me reset it. Right, so that all seems to be okay. So what we've got to do now is save it. So far so good. Right, so we need another mode now. So we've got different modes. PED mode, flag is active. I put flag on it, but it's just making me read the flag bit. Tell you what, let's get rid of the flag. It's confusing me. Everyone knows it's a flag. If it's lit up, it's a flag. PED request received, flag, that can stay. PED mode active, that's fine. Okay, AVG barriers are open, that's just that one there. So that could be some kind of output. That's just an output there, that's fine. AVG barriers are open. That comes out, tells the rest of the system. AVG, AGV. That's wrong, isn't it? AGV. Barriers are open. Right. I'll put that over there. I'll keep that in line with that. That's fine. Right. So, we need to go down the list now. Need to add some more stuff here so we can then integrate the Boolean. Integrate the Boolean. Apparently I'm a lucky one. AliExpress just says I am a lucky one. You get harassed by AI these days. You don't need people anymore to get harassed by AI. Right. So robot system okay for PED mode. So that's the robot system or the robot IO signalling the controller that it's okay for PED mode. So obviously that criteria needs to go up to this Boolean. So you need to switch that on in order to. I think it's. I think it's raised. I'll have to check it. I think it's raised high for okay. We'll have to check it. So that would go up to there. So the walkway in robot mode. AVG barriers are open. Right. So this is our confirmation that once the system has returned from. Once this is outputted to the PED walkway, and that's got a system full of criteria. If that's decided it's accomplished its walkway and then gone back to default, it will output a signal here. Barriers are open. AGV there, that's it. Alright, so that's our signal coming into the system. And it'll need to have that back off the system before we can signal back to the robot. AGV barriers are open, so yeah, we need to go and get my paperwork. Right, just be back in a second. Tell you what we do. What do we do? I'll just give you an intro. Back in a second. Right, got some paperwork now just to refresh what we're trying to do. So, brown 0 volts, but when the button is pressed it sends 5 to 12 volt. Constant signal, which is sent until the pedestrian is crossed. So that is our brown pair. I better write, oh it is, does say brown pair on it. Was the brown pair. So that signal goes out to the robot I/O and it's got a voltage on it. Constant signal which is sent until the pedestrian is crossed. Yeah. Yes, to tell the robot system not to send any more robots through. At the minute, we've got pedestrians crossing. We're in pedestrian. PED mode is active. Yeah, that's fine. That comes directly off this flag, so it can't really go wrong. Okay. Right, that's fine so far. Right. Blue pair. Right, so the blue must be voltage signal which will show the physical state of the barrier. When the AGV barrier is open, the state will be 0 volts. Right, okay. When the pedestrian barrier is open, it changes to 5 volts. Constant will be used to identify the state of the barriers and is independent of the orange and brown. Right, okay. So we've got a blue cables coming in. Walkway in robot mode. Now is that true? Blue must be a voltage signal which will show the physical state of the barrier. No, walkway in robot mode. No, that's not the right one, isn't it? Walkway in robot mode. Oh, barriers are open. Yeah, so it's not in the walkway. It's not in robot mode. It would be because you wouldn't get a signal on it. So that's coming back from. Must also be the voltage signal which will show the physical state of the barrier. So that's this side of it. Here, going out to the I/O control, but we need it as well. We need it, and this comes back off the walkway system. So 2 robot barriers will be open. The walkway system will be indicating it's in robot mode. So walkway in robot mode, yeah, exactly. So what is written there is exactly what we're expecting. It comes over from there and it's going over to this lamp just to say AVG barriers are open, and it's signaling, so we're ready. It's basically a ready signal, ready for. I don't think we're going to get a signal back off it, so we're ready for barrier. So it's tell it outputs to the robot I/O to yes, you can send the robots through. So, but does that mean we are in? If we're saying it's okay to send them through, then we're deemed to be in robot mode, even if there's non-robots gone through yet. We're in robot mode, so you do what you want to do while we're in that mode. So basically this can be used as a flag, but this doesn't get set and unset and locked open. It stays, it's continually feeding in from the walkway system, and the fact that the barriers are open. Anything other than the barriers open or the walkway system being in robot mode cancels out the cancels out the mode. Okay. So, but we need a signal at 0 volts. When the barrier is open, the state it'll be 0 volts. So we've got to this is a high signal output, unless we invert the signal. Now that will be high when we're in that mode, and when we're not in that mode it will be 0. When the AVG barrier is open, the state will be 0, yeah. So we've got the wrong transition state there, we need to make sure that's the right way around. Let's go back to the orange pair a minute. Signal, so typically 0 volt will be sent closed. Hang on, let's read it again. Signal back to confirm the barrier system is okay for the pedestrian barrier to open and robot's barrier to close. Typically 0 volt will be sent. Typically 0 volt will be sent as 5 to 12 volt constant signal until pedestrian barrier has closed and AVG barrier is opened again. So right, okay. Gets complicated when you've got to translate the writing. Translate the writing, what it means. So we want, so it's say 5 volt. So this is the bit with 5 to 12 volt. Just give me 1 voltage. So I'll just say when it's a high. When it's a high, you get a constant signal until the pedestrian barrier is closed. Yeah. So we've got to maintain that constant signal. So basically, it's just this signal here. So as soon as until the pedestrian barrier is closed and the AG barrier is open again. So we don't need to worry about the pedestrian barrier being closed, only that the AGV barrier is opened again and the system is in AVG mode, which is true when this signal is on. So this, it needs to be a flag. Don't know why I've got an OR on that. Let's just don't have an OR on that. So we'll move this over to our flag area. And we'll bring that over to there. There's no signal condition on this because the signal is the input. Whatever the input does, it follows that. Well, we do need the signal to be reproduced. So we're going to rename that now. Yes, indeed, the barriers are open, but if they're open and that we are in that mode, so we've got to say the robot mode is active. Robot mode is active, right. When that's lit, robot mode is active. If robot mode is active, now it's nice to have a transition timer. We don't want to go straight from PED mode to robot mode. Now, even though we're getting the signal coming straight in, we don't want a transition straight away, as that leaves it open to the last person coming through. Just need some control over the timing. I don't want quick transitions, I want controls transitions. Although that is done in the main software, but at least you need a bit more control here as well. Not much, just a little bit of control. So we want a timing. So when this becomes active, we need to turn this one off. Needs to turn that one off. So what we need is when we transition to the on. So we need a timer in there basically. Let's put a timer on it. So it needs to be a does it need to be a delay on timer? Probably. I can't remember which one it is now. What we got here? Function a on time. No, is it delay on? Yeah, it's a delay on, isn't it? Needs to be continuous. That's not the right one. Let's find another one. Function B. No, that's not it. Right. It's not labelled up very good, these. I don't think they're labelled up good. Cyclic timer. A bias. A timer. Let's try that one. Not sure now. I can't remember which one it is. Here it is it? So it's just a normal timer, right? So what we'll do is we're going to get a continuous signal off the system. So we come down here into this timer. It's not a boolean, so it's a timer. We'll alter that in a minute. So then your timer gives you a little bit of delay. So what? Also we need an output over to there, I believe it was. Okay. Let's nudge that down a little bit. That's better. Right. And that. Okay. So we need to set some timers. So it's an on delay. We need an on delay, but we want to, as soon as we get that signal, we want to reset this latch. So momentarily it won't be in PED mode, or it won't be in robot mode. Just momentarily. So on delay, off delay. So it's not an off delay. We might need an off delay, but we'll just half a second. You can give it a comment if you want. You can call it so it's robot mode. Right, okay. Robot mode active delay, on delay. On delay. Right, okay. Probably don't need a label sometimes, but then you can alter that timing. So we've got an on delay. Let's just try that simulation. So we just give it a permanent signal, and we've got counts half a second, then switches it on. Now you can't have that on with the other one on as well. So what we need to do is we need to set to reset the flags. It still needs to remember the flag, so it needs to reset this flag. So as soon as this becomes active, we need to reset this flag. Oh no, it's not when that becomes active, sorry. It's as soon as this powers on to reset the flag. So as soon as this becomes active, the delay is for us, so that can be switched off straight away. So whenever this is active, that will always be switched off. So it switches to pedestrian mode off straight away, stops it entirely. So let's see if we can do it like that. Okay. Right, let's give it a go. So we've got, we give it a pulse. We're in PED mode, is active. We've got our continuous signal. We're feeding back to there, so we can't take any other signals while we're in this mode. Won't set the flag any longer. Doesn't really matter. And now in order to cancel out the PED mode and go on to robot mode, this one becomes active. So you're still in PED mode, so you get a continuous signal going over to your robot system I/O board to tell it we're in PED mode. The pulse has gone out to the sequence on the the walkway system, and it's going through the motions. And but at which point actually this would have been a high to start with, so let's stop that and start again. So before we run it, this would have been high because the default mode for the walkway is robot mode. So then we run it, so we're in this mode, we're set into this mode. So conversely we need to come out of this mode. As soon as we come out of this mode, that's off the walkway system, literally with the barriers, the robot barriers up and the system in robot mode. So as soon as this gets a pulse out to change the mode, once you're in this mode, it should cancel this off. So I'm getting a continuous reset on there though. That might be a problem. Might be. Let's have a look. So we'll give it a pulse here. Now it's got through to there, it's remembered it. We're coming through to here, but we're getting no output because we've got a continuous mode here. So the output can never come out. So this needs to be a pulse on the reset. So that needs to be a pulse to let go of this, to let the signal through. So what we need to do is turn off there. Put in this mode thing here. We could probably, we need a pulse, we can either put the pulse there. So we want the pulse off it. I need to come up to there. Okay. So this is, at the minute it's going from off to on. So this will reset the other system as soon as this comes on. Yeah, so from on to off to on. Yeah, that's right. Right, let's give it a go. So put it into the on. Actually, you'll never notice that. So we'll have to go through a cycle in order to see that happen. So we're at default in robot mode, and we're outputting that when robot mode is active. So I do a PED-S request, right? So that's sent through a request to the system, and it would have started to go into that sequence. It would have dropped this mode off. It would have dropped that mode off, so we're out of robot mode as soon as the system had opened up, and now as soon as the walkway system was clear and returned back again, defaulted back to being robot barriers open, FAS walkway system in robot mode. It would have done that. So it's clear now, and we've got a PED mode active. We've got a permanent output, so we can't do anything with the flag while we're already active. That's fine. So we're active. Now when the PED mode goes through the sequence and it returns back to its normal state, this will become active again and reset the PED mode active to off. Turn this one to on, and we're okay to continue. Then we go, somebody comes along and requests again. That outputs the walkway system, starts to open, lets the person through. Once they've come through, as soon as it starts to go into that mode, this will become inactive. And once this is finished, it'll return automatically back to this system. So this system will then, so yeah, once this system, that's continuously telling the robot system we're in PED mode. As soon as its system has defaulted back, it'll be back on again. It'll reset the PED mode. Now I didn't see much of a transition there, so we might have to extend these timers a bit. Let's extend these timers just so we can keep a track on what's happening. So we'll change from, go from seconds. We'll go to seconds, 5 seconds. So 5 seconds, and then it'll switch. Now we've got another timer. Not at the minute, only that impulse. And we can put that on if you want. Make that a bit bigger. But, right, so let's make it seconds, and we'll have it. Is it an off delay? I can't remember what it was now. Off delay, wasn't it? Yeah. Yeah, off delay. Let's call it 2 seconds. Right, let's run it up again. So that's our default mode, so we start it from there. Started from there, so at the minute, yeah, it did count up. So as soon as you power up, it doesn't automatically give you straight away. It has to wait 5 seconds. And this is based on other criteria which we haven't introduced yet, like the override switch isn't pressed, and robot system okay for bed. We need it for PED mode. And we've also got another input. Yeah, there's one more on here. Right, there's one more which was supposed to be, I think it was the PED barriers. We'll have to have a look at that. Need to know when the PED barriers were definitely open. Or did we? Robot system okay for PED mode. So that would feed back into there. Override robot system. I'm sure one of these was to tell us that the... Oh no, that goes into the other... That's the walkway system, so that's fine. I'm going to have a drink of this. Right, so we're in robot mode, active. Somebody comes along, presses a button, that outputs the system takes over. As soon as it starts to raise, it comes out of that mode. Your PED mode is active. As soon as it's completed its cycle, your walkway returns again. It cancels that one out, and it's counting up, and that's obviously exaggerated. That's actually confusing now. Let's change that back again. That's because I've extended it, it's just confusing. Let's go back to, right, so we've got a an on delay. Yeah, just half a second off. Let's say a second. 1 second on delay. Right, and the rest is fine as it is, isn't it? Yeah. So that's the normal state. Yeah, so as soon as you power it up, now it would that would only give you that signal if the system was in robot mode, which is fine. So it passes the signal on, tells it's in robot mode. You give it a trigger. Problem there. See that we're in both modes at once, and that's because so we're in both modes at once, which is giving it a pulse to the walkway system, which then would have to knock this out. But this needs to go off as soon as that comes on. This needs to go off as soon as we get as soon as we're in PED mode, or is it when that flag gets set? No, I think it's when we're in this mode. So we need to turn off this mode as soon as we're in this one. So what we're going to have to do is put this through a boolean. So we need to disengage that from there. And that, and we need to come through a boolean. Is that a boolean? Yeah, boolean. We said the booleans were going to be down here, didn't we? So the timer can come over here. The boolean can go there. And that can directly set this mode. So the timer can set the boolean. It's all lined up. Okay. Got our booleans. Just answer the door, back in a second. So I got strange people knocking the door who walk off and don't want anything. Nightmare. Can't even. Never mind then. Right. Where was I? See, this is what happens. This is what happens. Anyway, I've got to get back into it now. Imagine at work with all sorts of phone calls going and all sorts of parcel deliveries. Anyway, right. Oh, I forgot what I was doing now. Shit. God. Right, so we're going to, we put in, need a boolean to not allow robot mode to exist if we're in PED mode. So we need to turn off that. So we need to feed we need to feed this mode here into one of these. So I need some space here. We're looking a mess now. Can that go up like that? Was that gonna it's covering our text stuff, isn't it? Oh, we should be able to do that. Hang on, no, we should be able to do... No, not that. That's it, we can do it that way, look. Come down off that one. So, we'll set the criteria. Probably have to add to it. So, that must be off. And this one must be on. Sorry about that. So that one must be off. It's a second input. So it must be on and off there like that. In order for that to be set. Then that carries through to this. Okay. Right, let's just see if that's okay. There's got to be more. There's going to be more to it. So that's our default mode. We start it running from there. So we're in this mode, and that is off, and it's let the signal carry on through. Then we're going to do a request. We set the flag. It's output the request. Immediately, this will go off on the other system, and see that? So I don't like that signal crossing over there. So I ought to make that one hit the top, and then let's do that now, because I can't stand it when it does that. Don't like that when it does that, so we're going to put this one to the second one, and this output to the first one. And that can just go to there and there. That's fine, and if you want you can pull that back a bit more. Right, okay, I mean that can then just drop down a touch. Okay, I'm going to change the boolean to off and on. Okay. And that can either go from there to there or to there like that. It doesn't matter, probably looks better like that. This could probably drop down as well. We'll leave it where it is though. Save it. Start it off again. So we run it from there. We've got on delay. We're in robot active mode. We set the flag to request across. It's pulsed the system. It's immediately dropped out here because the system will be opening. We're in PED mode is active. When it's finished, the system will return back, and the only way you've got to know about it is when this comes back on again. Immediately cancels out the PED mode. Yeah, through that way. We're in this robot mode again, so we give it another request. Immediately cancels this out, transitions straight to PED mode active. Now let's have a think about it. So we're going straight from robot mode is not active straight into PED mode active. Now the robot mode to be non-active, it must both barriers must be up, and the system must be telling us that it's in robot mode, and for that to happen the barriers are ready and it can go straight into pedcode active mode. But that's only if there's a flag been set. Otherwise it won't do it, it'll stay in. Yeah, that's normal. Let's try it again, go through the iteration one more time. So we're in this mode. We're actually ped active there, which should have taken us. Now that should have took us off. I forgot to switch it off because it's a separate system, so switch it off. We're still in ped mode active. Right, so I got confused now. Let's try again. So default mode started off. We're in robot active mode. If that ever gets on, it's because both robot barriers are open and the system knows that it's in robot mode. It's telling us never happen unless it is the right way around. 3 separate signals. A limit switch on both barriers that needs to be up, and the system needs to be outputting to tell us that it's in that mode. It won't output unless it's in that mode. So 3 things have to come together in series for that signal to be lit up. What we need then is someone to come along. We've got a continuous signal. Let's just check the criteria. Robot AVG barriers are open, was the blue pair, so that's a signal going to the robot IO on the blue pair. Let's just have a look. So the blue pair must always be a voltage signal which will show the physical state of the barrier. When AGV barrier is open, the state will be 0. When the pedestrian barrier is open, it changes to 5 volts. Signal will be used to identify the state of the barrier independent of the orange and brown. So it's when the barrier opens 0 volt. So it's given us a signal that goes through to probably a relay. It would have to operate a relay, and it would, which would depend on how we wired the digital signal. Going to the IO controller, just drop a state high or low, basically. So that can be figured via the relay to whatever state it wants. It's just a dry contact. They are actually two normally. It's normally open, going closed contact like a push button. You could wire the barrier to be open, the robot to be closed, typically 0 volt. So you'd probably have to put a resistor to drag it high, so when it's not outputting, or we could reverse the output. Don't like reversing the output, because we reverse the output when it's in a non-run state, you get a signal off it. So always want an active output to change the signal if you can do it. So I'd rather do it in a relay, single pole changeover relay that alters the voltage, because we've got special requirement for wanting voltage. So I'll have to put a note on that when we come to build it. Right, so that's the signal there. What other criteria? Orange, our signal back to confirm the barrier system is okay for the pedestrian barrier to open and robot barriers to close. Typically 0 volt will be sent. 12 volt console signal until pedestrian barriers have closed. An AGV, but is that from us or from them? Don't know. Let's try and read it again. Our signal back. Oh, that's their signal back from the robot IO controller. To confirm the barrier system, it is to confirm with the barrier system it is okay for the pedestrian barrier to open and robot barriers to close. Okay, so we need to be reading the open signal on the orange pair. Robot system okay for PED mode. So our signal back to confirm with the barrier sim is okay for the pedestrian barriers to open and the robot barriers to close. Right, so that's a signal we need to integrate into the Boolean. Which will then go to this Boolean. If it's outputting, if there's a signal coming into it like that, it means it needs to allow the pass-through of right, yeah, so we need to pass through this signal. The flag needs to be set. We need to go to there, and it also needs to go to this one. Right, so we need to introduce that into it. So we're gonna have to go one up to there. Don't know if we need a delay on it at the minute, or we won't put a delay on it, or just come into there. Right, well basically we're going to say when this is high, that is high, it'll pass a signal through. So now we need to alter this, instead of one being on, they need to both be on. Which is okay to go into PED mode, right, okay. And this one needs to be altered. So that'll be high. So we need to be watching for that. If that's high, it won't be it's gonna stop this. Stop this. Okay. So it can't output that if this is high. Which, because the controller's telling us it's okay for PED mode, so it can't be okay for robot mode. If it's okay for PED mode, so we need to, whatever we've got so far, introduce a 1 into that. So we've got off, on, and we need to be an off. Yeah, because if it's on, you can't have it. So that is on, off, off. That's right. On, off. Must be off. Yeah, so that is good. That's okay. Save it. Let's try it again. So we're going to go like this. We're going to start it. It's counting down. It's gone into there because the robot system is off. So it's allowing this. So we've got an off, on, off, which allows the output to the robot mode active. So that goes straight through to that. So we'll go through the motions, we give it a pulse. Now the pulse has come through, the flag is set because the robot system has not given us the go ahead with a high signal. That's as far as it's gone. We can give it multiple presses, doesn't matter. People are pressing buttons like mad trying to get through the walkway. The robot system says no, not ready for pedestrian mode. We're still in active mode, that's fine. So we're waiting for this signal now off the robot system. So the walkway in robot mode and the barriers are open still, yeah. That's fine, everything looks good. So we're waiting for this. So as soon as we've got the flag set, so as soon as we give this signal, the robot IO becomes telling us we're okay. it's handing over and shaking with us to say, go ahead, do what you got to do with the pedestrian. So we light that up, cancels out this one straight away, and sends this one to open. The robot barriers open on the blue pair. That's transitioning. Now that's still saying we're okay to open. Now this one, AVG barriers are no longer open because we've told it to go through the sequence, so it's in AVGs are open, so that's no, they're not open because they've closed. The first thing they do is close, so they've closed, and we're still in active mode here, and we're waiting now for the robot mode to return, the walkway system to return back to robot mode, which is done on a timing at the other system. So when that one kicks back in, cancels that one out and automatically engages, turns off something. Now it won't come through because we're waiting for this OK system for the PED. Robot system OK for PED. That needs to be off. So the robot system is going to have to hand over signal to this again. Now it's possibly waiting for another signal. So I missed what was going on there. Walkway in robot mode. So as soon as that goes off, robot AVG barriers are open. So it'll then have to turn this off. We'll have to check it. So as soon as that goes off, it goes back into this mode, so it knows what's going on. I'm gonna have to read the information again. Alright, let's see what we got there. Right, system, so it was the orange pair. Gets complicated trying to work out all the signals. I've got lots of stuff to read. Everything describes it in a slightly different way. I've written it down in a certain way. Blue pair, so we've got our blue pair. Walkway in robot mode. AVG barriers are open. So that's active on a blue pair. Yeah, so that's why we're in that mode. So blue pair, it says voltage signal to show physical state of barrier. When AGV barrier is open, the state will be 0 volt. Yeah, we said it was going to be outputting, but switch through relay, giving us 0 volt at the robot I/O controller. Then we want when pedestrian barriers open, it changes to 5 to 12 volt constant. When the barrier, so as soon as we let go, so I'm 0 volt now. As soon as we let go of the signal, it goes back to 5 to 12 volt constant. Used to identify the state of the barrier and is independent of the orange and the brown wire. That is independent of the. So now it won't. So it's ready now to take a signal. Robot system OK for PED mode. That's, I don't have control of that. That comes from the robot I/O system. Whenever it decides it wants to let us through. So if I constantly do anything here, it's just going to get so far through the system. It's not going to let it come out and change the mode. And it's waiting on this here to be told it's okay. Now we go OK, it immediately transitions over. So I'm not sure I like it to go straight from this to that one. I need kind of a little control over it. So let's go through the system again. Right, so that's the default mode. It can't be in. So that's, yeah, so that can be in that mode, and this can be while it's off. It means, what does it mean? So 5 volts. Change a constant signal will be used to identify the state of the barrier. When AGV barrier is open, the state will be 0 volt. When pedestrian barrier is open, it changes to 5 volt. Right, so that's not. So when the pedestrian barrier is open, it's saying, right, hang on. It's nightmare stuff. This is nothing compared to the last program. Yeah, so I don't know how I did it. The last program, it's crazy. Can I load it up again? Let's load another instance. What will happen if you don't load 2 of them? Right, so this is the one. This is the walkway system. Look at that lot. It's funny. This is just this bit. It's crazy. Yeah, not a good. If you ever want to do this job, don't do it. Do something else. Don't do this kind of work. And the funny thing is, I could write this in C++ with functions and loads of criteria, and do it very quickly and efficiently. Unfortunately, I can't program the Schneider Smart Relay with C++. Well, I could actually. It could, because it uses the same. It uses the 80 mega. It's not a 2560. It's the half the size one. It's the same thing, but half the memory, half the capability. So basically, you could wipe its firmware clear, the Schneider firmware, get rid of it, put an Arduino core on it, or whatever core you want, and you could program it in C++. I'll keep threatening to make my own PLC based on, there'll probably be an ESP32. Could be an AVR if you want to stay with AVR, not AVR. But I'd probably put a 2560 in it and just run Arduino core, because all this could be done in functions anyway. This is what people, they buy this relay, it's certified so to a certain degree, and they push the blame onto someone else. They say, well, I bought the thing and I programmed it just like you said you could do, so if it doesn't work, I don't know why they're selling it. That's what they could say. You put your Arduino controller on it you've made yourself, and everyone starts pointing the finger at that straight away. They say, oh, it's because you made it. No, it's not. It's because it's some other reason. But anyway, so you've got to go with this idea. It's not good, but what can you do? Anyway. Right, so we're getting there, sort of. It's an evil thing, I wouldn't recommend it. It's too many nested levels of thinking required. Or am I just getting old? Maybe just getting old. What's going on here? Nothing. French. Right. Let's have a look. So, time we got. Oh god, it's 4:15. 4 already. Shit. Right. Good news is I've only got another 45 minutes of misery on this. It's evil. I wouldn't wish it on anyone, but I mean, you have to be in the right frame. Imagine trying to do this in a busy office space. You've got no chance. Anyway, let's carry on. So, yeah, I want to introduce a delay. So when it transitions, we don't want to come straight out of this into this. Now we've got a delay going the one way, and what we want is a delay going the other way. And the flag will be set, and then once the flag is set and the boolean is active, we want a delay here to set it. Yeah, so we want probably disengage that from there, put another, copy that, we'll have that somewhere. Now we've got to have it over here somewhere, so we need to keep these lined up. So I'll probably move that over a bit. That's a broad French accent you got there, mate. Very broad. Right. I'm just gonna make us some space. Very important to make some space. If you don't have space, you can't do it. Alright, so we've got this timer here now. And we've got... So we're going to change the name of that. And it's going to be called PED mode. PED mode on delay. On delay, on delay. Yeehaw. Right, here we go. I don't like overlapping my flags. So, what can we do? Go that way a touch. And we can go that way. This is what takes the time. Yeah, I like to have it all lined up, otherwise I can't follow it. So we've got that going over there, but I can live with that. I can't live with that one though. Oh, I can just about live with that one. That can go there. Just about get together with that one, so that will go into there. Right, okay. Yeah. That's got to go over to there, so it needs to be lined up, so OCD. Right, so we've got our on delay, so once we've got our flag set, and the boolean has told us we're okay to go. Now we need some more boolean here, probably. We've got that. So walkway is in robot mode, and the area is open. So we can't, yeah, so that goes through to there. Okay, we'll give that a go. Right, default setting and run. Right, so we've had a delay before we get into robot mode. Somebody comes along as a request. So they've requested it, it's come through to the flag, it's not got past the boolean. We're waiting on this to become active. Now, okay, so it's waiting on that, it can't send through, so robot system is okay, the robot IO is telling us okay. And why would it tell us okay? Let's have a look. So we're in robot mode, is active. Right, so we haven't actually given it, oh no, we haven't given it a signal yet. Right, so we've got a little bit of a problem here. So that PED request voltage, right, so that's directly controlled from when it's released the signal, and the robot system is okay for PED mode. So that would suggest to me that the request, the continuous signal, needs to go through to the I/O controller, which you can never do. It's waiting on this. It's waiting on that. So robot system, hang on, let's just read the paperwork again. Right, so was the orange pair. Signal back to confirm whether barriers it is okay for the pedestrian barriers to open and the robot barriers to close. A 5 to 12 volt constant signal until pedestrian barriers have closed and the ABG barriers opened again. Right, so it shows a constant signal. So that signal there needs to be a constant one. And it's not. So it would be, wouldn't it? It would be like that. Because it's the opposite of that. So that one is outputting. Hang on, let's have a look at the blue one. This is why I'm putting it through a relay with be able to swap the signals. You do it for me anyway. Right, blue voltage signal to show physical state of barrier. When ABG barrier is open, the state will be 0 volt. So yeah, so it's 0 volt when it's energized, and then the orange pair, pedestrian barrier closed. Pedestrian barriers to open. It is for the pedestrian barrier to open and the robot barriers to close. 5 to 12 volt constant signal until pedestrian barriers have closed and AGV barriers have opened again. Right, so that would be then right. Yeah, so that's right. So as soon as we energize it, it pulls it down to ground basically. 0 volts. ABG barriers open, the state will be 0 volts. Yeah, that's it. So that's the what's confused is the signal, because you're not getting the signal is converted on a relay after, unless, yeah, because we're doing it that way because we don't want it to be in a non-operating state and giving the signals out. It needs to be in run mode, not stop mode. So we will have to wire through to the relay. So that is the right condition. Now it's out a continuous voltage to robot system. PED request. It's not really a PED request anymore, is it? Although it could be. Let's have a look. So the brown pair. Oh, this is brown pair, is it? Hang on. Voltage constant signal sent until pedestrian has crossed. This is where it gets confusing. Too many coloured wires. Too many wires doing similar things. Not a good idea ever. But anyway, it's what we've got. We've got to go with what they give us. Brown voltage. Constant signal sent until pedestrian is crossed. A constant signal. The RCS is checked and tell the robot to move. Confused. There's another official. That's my handwriting. Alright, brown. Typically 0, but when button is pressed, it sends a 5 to 12 volt constant signal, which is sent until the pedestrian is crossed. So that with a no output would be right. That's not right then, is it? That's not right. That's the brown. Oh, if I wrote brown pear instead of, I think I wrote orange. I should have wrote orange pear there. Yeah, I think I've wrote that wrong down wrong. Let's have a look. Yeah, I just copied it off there when I. Right. Yeah, I need to alter that. Anyway, I've got to go for an interim. Back in a bit. Okay. Où est le fromage? Le fromage dans la fenêtre. Where is the cheese? The cheese is in the window. Didn't I learn some useless stuff at school? Hello, monsieur. How can I help? Can I have the cheese from the window, please? Anyway. Right. Yeah, so what's getting confusing is the signals. We're relying on the output of the relay swapping, which is not a good idea. I need to see it on the screen. I can't really add the relay and signaling in here. So how can I do it? I need, when it says I need a 5 volt signal or 12 volt, I need to be at high on this end. Really? Yeah, we'll do it that way. But then if I do that, let's have a look. Brown volt, typically 0 volts. When the button is pressed, it sends. When what button is pressed? So that, yeah. The excusez-moi. Yeah. Button is pressed, it sends a 5 to 12 volt signal, constant signal, which is sent until the pedestrian is crossed. So it's sending out a 12 volt. This can't send 12 volt. This can just send an output. You've got to power it yourself through a relay or something else. Switch. So it wants to give out a constant signal until the pedestrian is crossed. Well, it doesn't need that signal because the system takes care of that. So what it needs to know I'm just trying to work out where on their system that goes to. I've got about 4 different sheets with 4 information. Some I've written myself, some the colleagues have written out, and I've got instructions, and they're all a bit weird. Trying to work it out. Alright, here's one for you, let's have a look. The logic. The Q7 would pass the area when brown and blue is low. Brown and blue is low. Indicates the AGV barrier is open. Brown and blue is low. Okay. Fair enough. Passenger barrier closed. ABG barrier is open, passenger barrier closed. Well, the system takes care of that. If the when the passenger needs to pass, brown goes high first as the button is pressed, and the Q7 that is going to pass the area would stop at the front of area while the Q7s are inside. The area would still continue passing. Oh, that's all taken care of in the other system. Once there's no Q7s inside the area, the orange would go high and the passenger barrier would open. Once there's no Q7s inside, yeah, that's all taken care of by the walkway system. The interface doesn't need to worry about that. Orange would go high, then the passenger barrier would open. Orange would go high, then the passenger barrier would open. AGV barrier close. RCS confirm. Okay to pass. Yeah, something wrong with me. I can't follow stuff like that. Right, is it in a different format? I think Andy, one of our guys, Andy, wrote it down, interpreted it. So let's say we'll see what he's written. Brown low, blue low, AGV open, PED closed. Request to pass. Brown is high, button pressed. Clear area, AGV. Orange high, start a program. Blue high. Blue high, yes, yellows, God. ABG barrier off, open limit. Clear area, pod. It's just statements. PED barriers closed. Brown is low, blue is high. Till AG, it doesn't mean anything to me. That might mean something to a mathematician, but not to my brain. Doesn't work that way. Right, let's have a look. So I was in a better frame of mind when I was working the initial ideas out. Right, so I started doing something on the 24th of the 9th. That's when I had a look at this previously. It's now the 15th, so it's 2 or 3 weeks later. Right. So walkway signal inputs. I want pedestrian request to cross from push buttons. That's blue pair I2. Blue pair walking. Walkway is in robot mode. That's a nightmare, isn't it? Q1. None of this makes any sense at all. There's 4 sheets that don't make no sense. Not to me anyway. Pad meter, right, okay. Supply the voltage scenario. So I did write a sheet out. Right, scenario 1. Q7 AVG robot FLT mode. Walkway system is powered up. Both pedestrian barriers are closed. Both Q7 AGV robot barriers are open. The safety zone between the barriers are clear of obstacles. This is scenario 1. Oh, that's just how the walkway system works, isn't it? Oh, just mentioned the pairs though. Barriers are open. The safety zone between the barriers are clear of obstacles. The pedestrian traffic lights are red. The walkway system is awaiting a push button request to cross from a pedestrian. The brown pair is low. The blue pair is low. The orange pair is low. This makes more sense to me now because I wrote this. Clear for Q7 AVG robot stroke FLT to pass freely. Alright, so we've got a brown pair is low. So the brown pair, oh, it is the brown pair, so that orange pair is wrong. Oh no, that's right. Because that's the pair that needs to connect to the walkway. So it starts off with a brown pair and it connects through to the orange pair, but then the brown pair is the one that's, yeah, so that will be low. Pedestrian traffic are red. The walkway system is awaiting a push button request to cross from a pedestrian. So that's it. So the brown pair is low. That's right. Alright, the blue pair must be low. That's an input. Hang on, sorry, the brown pair. So that's the input there. And you've got the blue pair. This is crazy. Problem is we've got the same colour codes in and out. So that's saying input. I've actually written input and output, so that's okay. Right, so the brown pair is low. The blue pair is low, so the blue pair is here. Robot in robot mode, AVG barriers are open. Right, so pedestrians are red. The walkway system is waiting a push button request to cross from a pedestrian. The brown pair is low, and the blue pair is low on the inputs. Well, my blue pair is high. And it's saying robot mode is active, that's why. This is scenario 1, so it'd have to be off. Right, okay. It's clear for this Q7. Oh, orange pair low. That's an output. So your orange pair are there. Orange pair are low. Is the output. Well, they're both low anyway. There's only one orange pair. It says it's clear for the A7 AV robot FLT to pass freely. So the orange pair output. I need to put input output on. Let's just change this a minute. So we've got this one here. Don't know if it'll let me put more text in. So that'll be the brown pair, that's an input. Right. Input, they are inputs, so we know it's an input really. This is a that's also an input. Input. Robot system OK for PED mode. Right, so that's an input. Well, they're all going to be inputs, but it's an output from the robot system, but it's an input. It's crazy.
Mike 6, Alpha November, November mobiles, is there a KSP?
Right, so I need a way to differentiate between where the signals are coming from. So we've got walkway. Right, okay, let's try again. So if we put walkway hyphen, so you can't format stuff from the walkway buttons, yeah. Yeah, it's not helping, is it, doing that way? We've got to keep it free of ambiguity. So walkway PED request impulse from walkway button. So right, so this is a PED request impulse from the walkway buttons. Okay. PED request impulse from walkway buttons. It's an input. It's a brown pair from the PED request. So I don't know. The more I add to it, the more complicated it gets, and more difficult to understand. PED request impulse from walkway buttons. Right. Status. So that's a request. Walkway in robot mode. Right, so this one is a status. So it's a status. So it'll output when it's in robot mode. That's the way my system works on the walkway. But the other one needs it in a different way. So the walkway in robot mode. So this is a status. Can't have too many texts, see? Status. It's a status. So the walkway. God. Walkway's in whatever. It's a status. I'll just say WW is in robot mode. Walkway in robot mode. That's it. And it's an input. Okay. So what about if I abbreviate where it's coming from? RB for robot, walkway, yeah. PED request impulse from walkway buttons. Right, so it's a status input. PED request impulse from WW buttons, walkway buttons, inputs. PED request impulse from walkway buttons, brown pair as an input. Status walkway. In robot mode, AVG barriers are open. blue pair as an input. Right, so we got robot system OK for PED mode. So robot system OK for PED mode. And it was the orange pair, so it's an output. Robot system OK for PED mode was the orange pair. So it was an orange pair, we can just get rid of that. So it's origin, it's an output. So it's a robot system output. Oh no, it's a status, isn't it? Okay, so if you say, so it's a status from the robot system. And we're OK for PED mode. The only reason we mentioned it was the orange part because that's about what was referenced in the documentation. So status from the RS robot system. So it is a status, and it's a hang on. So it's a robot system status. So it's a robot system status. So it's OK for PED mode. And it's an input. Well, we know it's an input because it's in the input. Right, let's go through this. So this is the walkway status. In robot mode, AVG barriers are open. In robot mode, right, that can stay like that. Right, this one next. And this is it's not a status, it's an input. So it's a walkway, not status, it's an input. PED request impulse from the buttons. So we don't need that. Walkway input, walkway status, they're all inputs. Status as an output, I don't know. It's all crazy to me, mate. Right, in robot mode, PED request impulse from buttons, walkway status, it's in robot mode, open. Walkway input button. Right, let's change that. Try to make logical sense. Walkway button. walkway buttons. Ped request impulse. Brown pair. Walkway buttons, ped request impulse. Walkway buttons, ped request, and it's an impulse. Okay, maybe I'll change that again. It's a ped request and it's a type of impulse. Impulse, right, okay. What's that over there? Why can't that go on the end? Now it can. It's got some glitches, so it didn't clear that up. So walkway buttons, it's a ped request, it's on the brown pair, it's an impulse, that makes sense. So this one's a walkway status. It's in a robot mode, AVG barriers are open. It's a blue pair, and it's an input. It's continuous. It is a continuous. That's an impulse. Right, let's put continuous. That might get us confused with the other bit there. I'll just say constant. It's a constant. Right, okay. Now this one, it's the... Excuse me. Right, I seem to have gone on there, sorry for a bit long. Do a few more minutes, so we'll have to pack up for tonight. That was a customer actually, just ringing up. I'm supposed to have been at work, but I've come here because of the noise at work. Can't concentrate. Yeah, so I've got a few things to change. That's okay. Yeah, so I'll be on this all day tomorrow, more than likely. Unless I come up with a solution quickly. It's not very likely. It's going to take a while. So I'll start again in the morning, about 8 o'clock, streaming probably all day, apart from lunchtime. Anyway, that's going to be it for now. We'll just save that. We'll catch you all. I'll probably be on a stream later doing my own stuff. Day job finished now, and I'll be back on my projects. It'll be the coin dispenser case, probably finishing off. There's a load of printed the rest of those off from yesterday's video, so I'll be able to get that. I've got to cut the case out and stuff. So anyway, I'll catch you all tomorrow. I'll be on most of the day tomorrow doing this same stuff. So talk to you again. I'm out of here. Have a good one. Bye bye.
This constitutes all available data. That information is not available.
If you didn't want the answer, you shouldn't have asked the question.
That is better. Our relationship will be best served if your statements are free of ambiguity.
My interpretation of the data leaves little room for error. I am checking. Kindly wait. I have the information you require.